Hi everyone, welcome to CAIE Science, and today we will be solving May June 2022 paper 2-3 of 9701. Okay, let's begin. Question number 1, part A, define first ionization energy. So it's the energy required when 1 mole of gaseous atom loses 1 electron to form gaseous ions. Okay, so this is the first ionization energy. Successive ionization energies for elements A are shown. Okay. Use table 1.1 to deduce the group of the periodic table that A belongs to. Okay, so from this ionization energy, look at that 6th and 7th ionization. There is a huge jump between 6th and 7th ionization energy, so it means that there is a change in shell. Okay, uh, so that's why 7th ionization energy is very high than the 6th ionization energy. It means that the shell is changed. So how many electrons are there in the valence shell? There are 6 electrons. So it means it is in the 6th group. Okay, group 6th, or you can say group 16th. Okay, so I am writing here group 6th. Okay, and what is the reason? Large increase after 6th ionization energy. Okay, there is a large jump between 6th and 7th ionization. Okay. So that tells us that the shell is changed. Okay. Question number part C. Sorry. Across period 3, there is a general trend for the first ionization energies to increase due to increase in attraction between nucleus and outer electron. Okay, explain why first ionization energy of sulfur is less than the first ionization energy of phosphorus. Okay. So from periodic table, if you see, this is sulfur and this is phosphorus and this is sulfur. Uh, According to question, and generally the first ionization energy increase across the period, but here the phosphorus has greater ionization energy than sulfur. Why is that? Because phosphorus has 15 electrons and sulfur has 16 electrons. So phosphorus has 15 proton number and sulfur has 16 proton number, so it means there are 16 electrons in sulfur and 15 electrons in phosphorus. So if you write the electronic configuration here, I'm just writing here 1s2, 2s2, 2p6, 3s2, and then there is 3p3. So this is the electronic configuration of phosphorus. Sorry, this is 3p3. So okay, it's correct. So in the 3p, if you see here, there are unpaired electrons in phosphorus, and in sulfur it has a 4p. So in 4p there is a spin pair repulsion. Okay, so this is spin pair repulsion outweighs the increased nuclear charge. So that's why phosphorus phosphorus has greater ionization energy. Okay, so what is the reason? There is spin pair spin pair repulsion in p orbital in sulfur. Okay, that outweighs increased nuclear charge. Okay, so this is the reason. Due to a spin pair, sulfur in a spin pair electrons repel each other, so this outweighs the increased nuclear charge. That's why sulfur has less first ionization energy than phosphorus. Part D. In aluminum 2 plus ion, the nuclear attraction for the outer electron is stronger than an atom of sodium. Okay, compare the electronic structure of aluminum 2 plus ion and an atom of sodium and explain why the third ionization energy of the aluminum is greater than the first ionization energy of sodium. So if you see in the periodic table, this is the sodium and this is aluminum. So here, this is sodium. Sodium has 11 proton number and 11 electrons, and aluminum atom has 13 proton number. So if you see here, this is sodium atom and we have aluminum 2 plus ion, so it means now it also has 11 electrons. Aluminum 2 plus ion has 11 electrons, but it has same proton number because proton number does not change. So they both have aluminum 2 plus ion and sodium has both have same number of electrons but different number of protons, because and aluminum has larger proton number, so it will have a greater third ionization energy than the first ionization energy of sodium because there is more nuclear attraction. Okay, so what will you write? Both remove electron from 3s1. Okay, or you can write as aluminum and sodium have same electronic configuration. L2 plus and sodium have same electronic configuration. Okay, so and L2 plus has greater nuclear charge. Okay, so that's why third ionization energy of aluminum is greater than the first ionization energy of sodium. Okay, this is the reason. They have same number of electrons and but the proton number of aluminum 2 plus is greater. Okay, part E. An isotope of copper has a relative isotopic mass of 65. Complete table 1.2 for an atom of copper 65. So if you see from periodic table what is the proton number of copper, this is 29. Okay, so atomic number is 29. And what are the nuclear number? What is the nuclear number? Nuclear number is number of protons plus number of neutrons. So and it is also called mass number, so it is this isotopic mass, so this is going to be the nuclear number. And how many number of neutrons? So if you subtract 65 from 29, so you will get 36. Okay, and what is going to be the electronic configuration? So in atom there are same number of protons and electrons, so it will have 29 electrons, and So what will be the electronic arrangement? 1s2, 2s2, 2p6, 3s2, 3p6, and then we have 4s1, 4s2, and 3d9, but uh, we will write here as 4s1 and 3d10 because this will give uh, the stable 3d shell. Okay, so this will be 3d10 and 4s1. So this is the electronic configuration of copper. Okay, part F. The element copper has a relative atomic mass of 63.5. Calculate how many atoms are present at 1.05 gram of copper. So first we will calculate moles. Moles is equals to mass upon atomic mass, relative atomic mass. So it has mass of 1.05 divided by 63.5. Okay, so here you will get um, 0.0165. Okay, now you will multiply it with Avogadro's number, so you will get number of atoms. Okay, n is equals to moles multiplied by Avogadro's constant. So 0.016 multiplied by 0.6.02 into 10 to the power 23. So you will get 9.95 into 10 to the power 21. So this much electrons. Okay, 98. So you can write it as 9.96 into 10 to the power 21. Okay, moving towards next part. Copper has a melting point of 1085 degrees Celsius and high electrical conductivity. Explain these properties of copper by referring to its structure and bonding. So it has a high melting point, so it must be a giant structure, and it is the electrical conductor, so it must have metallic bonding. Okay, metals conduct electricity in solid form and they have a high melting points, so it has a giant metallic structure. Okay, so what will you write? There are stronger bonds in giant metallic structure. And why these conduct electricity? Because there are delocalized electrons. Okay, that's why they conduct electricity. And delocalized electrons are free to move, are free to move throughout the structure. Okay, so that's why it is the electrical conductor, and it has a high melting point. Question number 2. Period 3 elements and their compounds show trend in their physical properties. Okay, on figure 2.1, sketch a graph to show the melting points of first 5 elements in period 3. So melting point, firstly it increases, then it decreases. So this is sodium, then magnesium, then it's aluminum, and there is a small increase between magnesium and aluminum, and then there is a large increase in silicon because silicon has a giant structure. Then phosphorus has a low melting point because phosphorus has a simple molecular structure. So this is like this, then like this, then like this. Sorry, my diagram is not as accurate, but you can see from the marking scheme how to draw. Okay, something like this. Okay, moving towards next part. Complete table 2.1 with the information for sodium chloride and phosphorus 5 chloride set at room temperature. So both are solids at room temperatures. Sodium chloride is a solid and phosphorus 5. This is PCl5. This is also a solid at room temperature. Name of change which occurs on addition of water. So when water is added, sodium chloride dissolves because it is soluble in water, and when PCl5 is added to water, it hydrolyzes and it forms phosphoric acid. So this is hydrolysis. Okay, and what is the pH of final solution? It has a pH of 7, and when it forms phosphoric acid, so it is in a strong acid, and strong acids have very low pH, so it will have pH between 1 to 2. It will have pH between 1 to 2, so you can write either 1 or 2. Okay. Part B. Tennessine is an unstable man-made element. It is found below astatine in group 17. Okay, the chemical properties of TS and its compounds have only been predicted. Suggest an equation for the reaction of sodium tennesside and bromine. Okay, assume that the TS follows the same trends as the other elements in group 17. Okay, so if this follows same trends as the other groups, as the other members, so down the group reactivity decreases in group 17. So this bromine will displace this tennessine. Okay, so it will form sodium bromide plus tennessine. Okay, like this. An explanation. What is the explanation? There is decrease in reactivity down the group, or you can say reducing the strength of halide increases down the group. Okay, or you can write it as tennessine reduces bromine. Okay, or you can write as reactivity decreases down the group 17. Okay, so this is the reason. Okay, moving towards second part. Some scientists predict that the tennessine has properties typical of metals like copper. Okay, so complete table 2.2 with the predicted melting point of tennessine and the lattice structure of solid chlorine, bromine, and tennessine. Okay. So if this assume that the tennessine has a properties typical of metal. So if this has a properties like tennis like metals like copper, so it will have a high melting point. So it can be could have melting point of 1000 degrees Celsius. Okay, so it will have a high melting point. Okay, and it will have a giant structure. Okay, giant metallic structure, tennessine. And for lattice structures of crystalline solids of chlorine, it will have a simple molecular structure. Okay, that's why they have very low melting point. Simple molecular. Okay, moving towards next part. Question number 3. G belongs to a group of compounds called ethers. Okay, when G is heated, thermal decomposition occurs. Okay, so the atoms in a molecule of carbon monoxide are held together by a triple covalent bond. One of these bonds is a coordinate covalent bond. Okay, draw a dot and cross diagram to show the arrangement of electrons in carbon monoxide molecule. Use dot for oxygen and cross for carbon. So the electronic configuration of carbon monoxide has a triple bond and it has a one dative bond. Okay, this is carbon, this is oxygen, and we have to replace carbon with X. Okay, this is X, this is cross. So carbon shares two of its electrons, outer shell electrons, in this sharing of into covalent bond, and two of its electrons are unpaired, unpaired, unpaired. Okay, so and the oxygen forms here a dative bond like this, and it has six electrons in its outer shell because it is a group member of group 16 or group 6, you can say. So it will have six electrons, and four of its electrons are in sharing between these two atoms, and two of its electron will be here. Okay, so this is the electronic configuration or electronic dot and cross diagram of carbon monoxide. Okay, calculate the bond energy of carbon monoxide using the bond energies values in table 3.1 and the enthalpy change for the thermal decomposition of G. Okay, so we are giving some of the bond energies and we are giving structure of ether. Okay, G. So I'm just drawing structure here. Okay, so this is the structure of ether, G. Okay, so it has two carbon carbon bonds, so it will have a first in the to calculate the bond energy we have to form an equation to how to calculate enthalpy change. So enthalpy change is calculated from when we subtract reactants bond energies from uh, minus products bond energies, so we will get enthalpy change. So here we have in ether two carbon in carbon carbon bonds, like this is the bond energy of carbon carbon bonds, single carbon carbon bonds, so it will be 3350 multiplied by 2, then plus it has two carbon and oxygen single bond, so it will have a 360 multiplied by 2 plus, and it has 1 2 3 4 5 6 7 8 9 10 10 carbon hydrogen bonds. Okay, so like this, minus, then we on the product side we have ethane, and its structure of ethane is like this. Okay, and we have carbon monoxide, we have structure of carbon monoxide like this, and this is the bond energy which we have to calculate. Then we have methane, CH4. Okay, this is the structure of methane. So here in ethane we have one carbon carbon bond, so 350 plus, then we have a carbon hydrogen bond like a 1 2 3 4 5 6 6 carbon and hydrogen bonds. Then we have another carbon hydrogen bonds in methane, 1 2 3 4, and then we have to calculate the bond energy of carbon monoxide. So this is equals to the enthalpy change of reaction, which is -7. Okay, -7. So from here you will calculate the enthalpy change. If you add these all, you will get I guess 5 520, and then minus 4450 plus carbon carbon triple bond with oxygen, carbon oxygen triple bond is equals to -7. Okay, so from here you will get a bond energy of carbon monoxide, carbon oxygen triple bond, which is 10 plus 1077. Okay, bond energies are always in are always positive. Okay, these can't be negative. So this is the bond energy of carbon monoxide or carbon oxygen triple bond. Okay, part 3. When G is heated in a sealed container, an equilibrium is established. Okay, complete the expression for the equilibrium constant Kc for this reaction. Okay, so this is the ratio of the concentration of products divided by concentration of reactants. So products are here P2H6, which is ethane, concentration of ethane. Then we have carbon monoxide. Then we have methane. And on the reactant side, we have G. Okay, so this is the electronic configuration. And if you calculate units here, this will have units of mole per mole cube and dm cube minus 3 divided by mole per dm cube. Okay, so here this 3 is cancelled out. You will get mole square dm cube minus 6. Sorry, minus 6. Okay, this will be the units. Part 4. Thermal decomposition of G in the presence of iodine affects the activation energy for the reaction. Okay, table 3.1 shows the activation energy for the thermal decomposition of G with and without iodine. Okay, so with iodine the activation energy is low, and without iodine activation energy is high. So what is it, what effect adding iodine to the reaction mixture has on the value of Kc? Explain your answer. So it will have a here you can see that the iodine is behaving as in a catalyst, because catalyst decrease the activation energy by an alternative path. Okay, so with iodine the activation energy is low, so iodine is behaving as a catalyst, and catalysts have no effect on the value of Kc, so it will have a effect. No effect. Okay, because iodine is a catalyst and does not does not affect position of equilibrium. Okay, this will not increase or decrease the yield. Okay, or does not change the position of equilibrium. Catalysts just increase the rate of reaction. Okay, they don't have any of effect on the position of equilibrium or value of Kc. Okay, Kc is temperature dependent. If you increase or decrease the temperature, the value of Kc will change. Okay, figure 3.2 shows the Boltzmann distribution of energies for molecule of G at constant temperature T. Sketch on figure 3.2 the Boltzmann distribution energies for molecule of G at higher temperature So at a higher temperature, you will have a more number of molecules with energy greater than activation energy. Okay, so here the graph will be like this, and here you can draw this. Activation energy will not change, but more particles will have energy greater than activation energy. So graph will be something like this. Okay, something like this. Okay, part B. The functional group in G is an oxygen atom bonding to two carbon atoms. Okay, so this is the functional group. Okay, GH and GH and J are structural isomers with molecular formula C4H10O. Okay, H and J are straight chain molecules. Okay, they don't have any branch. Table 3.1 shows the boiling points and the reactions of G, H, and J when heated under reflux with the acidified potassium dichromate. Okay, so G has no reaction with potassium dichromate, the color remains orange, and the H and J are both oxidized. That's why the orange color change into green. Okay, so it must have alcohol groups H and J, because alcohols they oxidize into carboxylic acid or aldehydes. Okay, identify the type of structural isomerism shown between G and H. G and H. So in H you will have alcohol group, OH group, and this in this you will also have alcohol groups. Okay, using the information in the table 3.1. So there is a functional group isomerism. Okay, functional group isomerism, and identify the type of structural isomerism shown between H and J. So in H and J there is maybe the position of there are no chain. These both H and J are both straight chain molecules, so there must be position isomerism. So because position of this functional group in H and J will be different. Okay, so here in H and J there will be positional isomerism. Okay, and then it is saying draw a possible structure of H and J. State the systematic names for each structure. So this has a molecular formula C4H10O. So if I draw H, so I can possible structures. Okay, so this will be CH3, CH2, CH, CHOH, and CH3 like this, and this is CH3, CH3, CH2, CH2, and CH2OH. Okay, because why this H is in this on the second in the middle of the this group OH group, because this OH has you can say that this has a greater boiling point. Okay, and this J has a less boiling point. Okay, so this OH is attached to two carbon atoms. Okay, OH, the carbon which has functional group is attached to two carbon atoms, so it is greater bonding. Okay, so this is the butane 2 ol, and this is going to be butane 1 ol, butane 2 ol, and this is butane 1-ol. Okay, moving towards next part. K has a molecular formula C3H6O. When K is added to 2,4-dinitrophenol hydrogen, an orange precipitate forms. Okay, so it must have a carbonyl group. This is the test for carbonyl group. When K is warmed with tolerance reagent, a silver mirror pipette is formed. So it must have aldehyde group. Okay, ketones don't give a positive test with tolerance reagent, but aldehydes do. So draw a displayed formula of K. So K must be aldehyde, and what will be the displayed formula? It will have a displayed formula like this. This is the aldehyde. Okay, this is propanol. Moving to our next question. 2-methylpropene reacts with HCl at room temperature. Okay, the major product is the 2-chloro-2-methylpropane. Okay, complete table 4.1 to show the structure of the intermediate and the mechanism for this reaction. Reaction include charges, dipoles, lone pairs of electrons, and curly arrows as appropriate. So this alkene has a double bond, so it is acting as a nucleophile, and here you will have a polarization. Because chlorine is more electronegative, so it will have a partial negative charge, and H will have a partial positive charge. Okay, and this double bond will attract this hydrogen. Okay, attack this hydrogen, and here you will have a intermediate like this. uh, Plus. Okay, why this is the intermediate? Because this is the tertiary carbocation, and tertiary carbocations are more stable, so it is likely to form. Okay, then the chlorine will attack on this carbon, and it will form 2-chloro-2-methyl propane. Okay, so this is the mechanism for this reaction. Okay, explain why in this reaction 2-chloro-2-methylpropane is produced at higher yield than the 1-chloro-methylpropane. Because the intermediate that forms is the tertiary carbocation, and it is more stable due to greater inductive effect of more alkyl groups. Alkyl groups are electron donating groups, so they will stabilize this positive charge on this carbon. Okay, so this is more stable than the intermediate formed when 1-chloro-2-methylpropane is formed. So this is produced in greater yield. Okay, so what is the reason? Intermediate formed is more stable. And why more stable? Because due to greater inductive effect of more of three alkyl groups, alkyl or methyl groups. Okay, or you can write more alkyl groups. Okay, that's why this has a this is stable. And in the 1-chloropropane, if you write the mechanism, so you will have an intermediate like this. This would be the intermediate. So it has only one carbon attached to it, this carbon. Okay, the carbon which has a charge of positive charge, so it has only one carbon attached, so it will have only one alkyl group attached, So it will have less it will be less stable because less inductive effect of less alkyl groups. Okay. Part B. Two bottles labeled Q and M each contain stretched halogen with a molecular formula C4H9X, where X represents Cl, Br, or I, which is chlorine, bromine, or iodine. Okay. A sample from each bottle is added to separate samples of equal amounts of aqueous silver nitrate in ethanol. Okay. In each reaction, the same organic product T and a precipitate are made, as shown in figure 4.1, 4.2, sorry. Okay, Q and M are both reacted with silver nitrate in ethanol, so they form T and a precipitate. Okay, so table 4.1 describes the color of each precipitate that made. When Q is reacted, white PPT is formed, and there is yellow PPT with M. We identify the functional group present in T and the name the type of reaction that occurs using the information in figure 4.1 and 4.2 and 4.1. So this is the substitution reaction. Okay, the X group is substituted from the molecule C4H9X. Okay. Okay, so and what will be the functional group present here? It will be a hydroxide group, hydroxyl. Oh, sorry, hydroxyl. Hydroxyl means OH group. This will OH group will be formed when the silver nitrate is added in ethanol. Okay, so what is the type of reaction? This is the substitution reaction. Okay, construct an ionic equation to describe the formation of yellow precipitate produced when M reacts with silver nitrate in ethanol. So M yellow precipitate shows that it is it has iodide ions. Okay, because and white precipitate shows that it has chloride ions, because silver chloride is white precipitate and silver iodide is a yellow precipitate. So what will be the ionic equation? Ionic equation will be uh, silver ions reacts with iodide ions to form silver iodide as a solid. Okay, or you are not necessary to include states here, but sometimes it says include the states. Okay, so these both ions will be in aqueous and this solid form will be solid. Okay, describe which reagent Q or more will produce precipitate more quickly when each is added to silver nitrate in ethanol. So M is producing a yellow precipitate, so yellow precipitate will be formed more quickly because this M will have a carbon and iodine bond, and this will have Q will have carbon and Cl bond. So carbon and iodine bond is weaker, so it will be broken more easily and more quickly. M will form quickly precipitate because carbon and iodine bond is weaker. Okay, when pure T is added to alkaline iodine, a yellow precipitate and an anion L are made. Okay, so identify the L. This is the yellow precipitate and this is the test for iodine, alkaline iodine. This is the test for you can say alka methyl group. Okay, so what will be the anion L? So this will be this has a 4 T has a 4 carbon atoms. One of them will be formed in yellow precipitate, so the anion remaining will be carbozylate ion. Okay, so this will be CH3 CH2 C double bond O minus ion. Okay, this will be the ion. And this is propanoid ion. Deduce the structure of the straight chain halogen alkane M. So M has the structure of like this. It has the functional group has the methyl group attached to it. Okay, so it has a methyl group attached, so it will must be like this. Okay, and M has a iodine. Okay, so this iodine is at the carbon which has iodine is attached to methyl also. So that's why this shows a positive test with alkaline iodine and forms a yellow precipitate. Okay, and the remaining part which will give you the carboxylic acid. Okay, moving towards next question. Butene 2 but2 reacts with K-4 to form organic product Y. Okay, Y does not react with sodium carbonate. A gas is produced when an excess of sodium is added to Y. Okay, describe the conditions for the K-4 used in the reaction to form Y from but2. So when but2 is reacted when but2 is reacted with cold K-4, this forms this compound, which is this forms this compound, which is uh, 2,3 hydroxyl hydroxyl butanol. Okay, these OH groups are both attached to it. Okay, okay. So this will form when cold OH is cold K-4 is used, and when the hot K-4 is used, the carbon double bond is broken down, and this will form a carboxylic acid group like this. Okay, the double bond will be broken and carboxylic acid will form. But there is no carboxylic acid formed because this sodium carbonate does not react with Y, the product Y. So if Y is not reacting with sodium carbonate, but it is reacting with sodium, so it must be this compound. Okay, sorry. So it must be this compound. Okay, so what are the conditions for KMnO4? This is cold plus dilute. Okay, part 2. 24 cm cube of gas is produced when an excess of sodium is added to 0.001 mole of Y. Okay, when measured under room conditions. Okay, assume that 1 mole of gas occupies 24 dm cube under room conditions. Deduce the possible structure of Y. So the structure of Y I have already shown you. This is the structure. Okay, HOH. This is the structure, and this reaction is called mild oxidation reaction. Okay, and what is the reason why this is the structure? Because when zero you if you calculate the moles of gas produced, okay, volume is equals to 24 multiplied by n. So moles is equals to volume is in for 24 multiplied by 10 to power minus 3, because you have to convert it to dm cube. Okay, 24. So you have moles of 0.001 moles, and this is also the moles of Y. Okay, So same number of moles of Y and uh, N, the volume of gas, and the gas produces hydrogen, by the way. This sodium will replace the H group from the OH group, okay, and from here, okay, these both hydrogen groups from OH will be removed by or substituted by sodium, okay. So if you write the equation ROH plus sodium, if they react, you will get RONA plus hydrogen. So once if there is a one OH, so the moles of hydrogen which will be formed will be 0.5, but there are same number of moles of product Y and hydrogen, so there must be two alcohols, and there are two alcohols OH groups, so this will form uh, the 1 mole of hydrogen, okay. So that's the reason, okay. So this is the structure of Y. Moving to our next part, which is part B. Z contains three types of atoms: carbon, hydrogen, and halogen. Okay, the mass spectrum of Z is recorded. Figure 5.1 shows a section of mass spectrum at uh, greater than, which is greater than 63. Okay, the fragment at uh, mass to charge ratio at 64 is a molecular ion peak. Okay, so this will give you the MR of the molecule Z. Okay, so deduce the number of carbon atoms present in a molecule of Z using the figure 5.1. Show your working. Okay, so number of carbon atoms are deduced from the formula, which you have to remember. This is the formula: N is equals to 100 upon 1 1.1 multiplied by abundance of M plus 1 peak and divided by abundance of M plus peak. So N represents the number of carbon atoms, and 100 divided by 1.1 multiplied by abundance of 1 M plus peak is this molecular ion peak, and it has a abundance of 100, and the M plus 1 peak is this 65 peak, and it has abundance of 2.2. So here you will get number of carbons, which is 2. So number of carbon, this is it has two carbon atoms, okay. So this is the answer, okay. 2 carbon, it contains 2 carbon, okay. Deduce which halogen is present in Z. Explain your answer, okay. So if you see 64, and there is also a peak at 66, which has abundance of 33.3, and the halogen peak also gives M plus 2 peak. If a halogen is present, it will give you a M plus 2 peak, okay. So this is the M plus peak, and this is the M plus 2 peak, okay. So M plus 2 peak has an abundance of 33.3, and if you calculate the ratio 33.3 to 100, so it is the ratio 3:1, okay. And if you remember, chlorine 35 and chlorine 37 has a percentage ratio of 75 and 25. This is the abundance ratio of chlorine 35 isotope and chlorine 37. So this also has a ratio of 3:1. So this halogen must be chlorine, okay, because chlorine has a ratio of uh, 3:1. So this is and if you are So if you say if it is bromine, bromine has 79 and 81 isotopes, and these isotopes are almost in same abundance, 50%. So this will have a 1 to 1 ratio. So this can't be bromine. Okay, so this is chlorine. Okay, so these abundances of chlorine, you have to remember these. Okay, so which halogen is present? This is chlorine. Okay, and why chlorine? Because peak at m plus 2 represent represents molecular ion with Cl37. Okay, or you can write that m plus, or you can write as m plus peak, and m plus 2 peak has a ratio of 3:1. This is also correct. Okay, moving towards next part. There are also peaks at 29 and 49. Okay, so suggest the formula of these fragments and reduce the name of the Z. So now you know that you have in the Z, you have, it says that it contains only 3 atoms. Okay, carbon, hydrogen and halogen. Okay, and the halogen here we have found that it contains chlorine, and then we found that it contains 2 carbon. So if it contains 2 carbon and hydrogen and halogen only, so it must have halogen is this halogen. And if I draw the structure like this, we don't know exactly how many halogens are there, but let's say we say that it contains 1 halogen, for example. We'll check now that whether it contains 1 halogen or 2 or more. Okay, so let's say this is the structure of Z. So if I break the structure from here, so this is giving me a peak at this has a molecular formula 29. So the peak at 29 is due to ethyl group. Okay, so the peak at 29, if you calculate the this mr of this part, this will give you the mass mr of 29. So this molecular peak at 29 shows that it contains ethyl group. Okay, so there is only 1 halogen. Okay, ethyl group, so T2H5 plus. Okay, and then if I break the same molecule from here, now calculate the okay, if I break the it from here. Okay, from here, sorry. So now this part will give me the peak. If you calculate this, it's mr 35 plus 12 plus 2, so this is going to be 49. So the peak at 49 is due to this group, CH2 plus CH2Cl plus CH2Cl plus. Okay, so now you know that the this is the correct structure. Okay, so the name of Z is chloroethane. Okay, so the name of this is chloroethane. This is the correct structure. Okay, so here you are complete. This paper is completed. I hope you like the video. If you have any queries, you can ask me in the comment box. And if you haven't subscribed my YouTube channel, please subscribe the channel for more videos. And thank you for watching.